Part C. Explain why there is a force of attraction between a charged rod and an uncharged isolated metal sphere, and why this force increases when the sphere is earthed. Okay, so we've got two situations. It's good to draw a quick sketch so that we can see what's going on. So, force of attraction between a charged rod and an uncharged isolated metal sphere. So here's your charged rod. We'll start off just saying it's negatively charged. I don't think it'll matter in the long run, but we'll start with negative, and then we'll consider it from the perspective of positive, just to double check. And our isolated metal sphere, which is uncharged, so it's got an equal number of protons and electrons in it to create an overall charge balance. So we're wanting to explain why there is a force of attraction. Okay, that's drawing this metal ball up. You may have seen a physics experiment which has the Van de Graaff generator and a hanging metal ball which gets drawn close as the Van de Graaff generator runs. And it hits it and it bounces back, and it hits it and bounces back, goes back and forth. This is the same phenomenon. Okay, so what we need to look at first of all is if this is attracted to something negatively charged, that means the ball has to become positively charged in some way. Okay, so there has to be some sort of positive charge in some way on that ball. Now, for that to happen, electrons have to move. Now they can't move off, they can't completely move off the ball, but they can move, because remember, it's the electrons that will move and the protons stay in place roughly where the atoms are. The electrons can jump from atom to atom, and yeah, so the electrons they can't move off anyway, so they just move to the far side of the ball, leaving a positive charge behind. So overall, the whole thing is still neutral or uncharged, as this question says, but we've got a charge imbalance within that whole system, which means there'll be a force of attraction or between the two, drawing them to each other due to that electrostatic charge. Okay, so question, would that be the same if this was positively charged? So let's quickly consider that. If this was positively charged, then the electrons could still move inside this sphere, but this time instead of moving away, they'd be attracted to the opposite. So you get electrons on the top side, and you get the positive charges on the bottom side. So charge imbalance happens, you still get the force, so it doesn't matter what charge it is. Okay, so that's explaining why there is a force of attraction, because the electrons are able to shift, leaving a charge imbalance on the sphere. So explaining why this force increases when the sphere is earthed. So same situation, but this time we earth it, or ground it, or if you like you can call it a source or a sink for electrons. It's an electron source or sink, which means when you bring this charged rod close, it'll be, if it's negatively charged, the electrons will be pushed away and they can go all the way down to ground, or if it's positively charged, it's got an extra supply of electrons which can bring them up. But either way, whatever the situation out of those two, whether it's positive or negative, this sphere will receive a higher charge, which will mean the relative charge between the sphere and the rod will be higher, so the charge difference, if you like, which means a greater charge imbalance means a greater force of attraction. And that's it, that's how it works.